You are not touching your phone. You are not touching the chair beneath you. You are not even touching your own skin. At this exact moment, as your fingers press against what feels like a solid surface, physics says that no true contact is taking place. What you experience as touch is not the meeting of solid substances, but the interaction of invisible forces. The shock is not poetic, it is precise. The solid world that seems so obvious, so dependable, so physically present, is built on a foundation that contains almost no solidity at all. From childhood, we inherit simple narratives. Objects are solid because they are made of matter, and matter is solid because it is made of tightly packed particles. Tables feel hard because they are densely filled with stuff. Walls stop us because there is something physically in the way. This explanation feels complete because it matches our senses. When you knock on wood, you hear resistance. When you push a wall, it pushes back. When you strike something hard, pain confirms impact. The conclusion seems unavoidable. Contact has occurred. But physics does not operate on how things feel. It operates on what fundamentally exists.
Inside every solid object is the atom, and inside every atom is something radically unintuitive. If you could magnify a single atom to the size of a stadium, the nucleus would be a small marble at the center, and the electrons would occupy regions spread out far from it. Between them lies vast emptiness, not metaphorical emptiness, not diluted matter, but space in which there is no solid substance at all. Almost the entire volume of every atom in your body is empty. The same is true for the wall in front of you. If atoms are mostly empty, and both you and the wall are made of atoms, then the immediate question arises: what is actually stopping you?
To answer that, we must abandon the image of atoms as miniature solar systems. Electrons do not orbit nuclei like planets circling a star. They exist as quantum mechanical probability distributions, regions where they are likely to be found if measured. This description comes from the mathematics of wave functions first formalized by physicists such as Erwin Schrödinger. The deeper we look, the less the atom resembles a cluster of solid grains, and the more it resembles a dynamic pattern governed by equations. What we once imagined as tiny physical beads turn out to be excitations of underlying fields. In modern quantum field theory, the most fundamental description we have, particles are not independent little objects moving through empty space. They are disturbances in fields that exist everywhere. An electron is not a miniature ball, it is an excitation in the electron field. A photon is an excitation in the electron field. These fields do not occupy space the way objects do. They are conditions of space itself. What we call matter is a stable pattern of excitation in these fields. Solidity then is not a property of tiny hard components, but an emergent effect arising from field interaction. When your hand moves toward a table, the atoms in your skin approach the atoms in the wood, but the nuclei never collide like billiard balls. The electrons do not smash together as solid spheres. Instead, the dominant effect comes from the electromagnetic force. Electrons carry negative charge. The electrons in your hand repel the electrons in the table. That repulsion grows dramatically as the distance shrinks. Before any classical contact could occur, the electromagnetic force increases steeply enough to halt further approach. Your hand stops not because two solid substances are fused, but because charges resist overlap. The sensation of hardness is the sensation of electromagnetic resistance transmitted through your nerves. This is where the language trap begins. We use words like object, surface, and contact as though they refer to fundamental realities. In fact, they refer to emergent behavior. There is always a microscopic gap between the atoms of your hand and the atoms of the wall. The distance is unimaginably small, but it is not zero. The electron's probability clouds prevent deeper penetration through repulsive interaction. In effect, you are hovering just above the surface, separated by a cushion of force. The solidity you feel is not compression of solid grains, it is force pushing back. Yet repulsion is not the only player. A deeper quantum rule further enforces stability, the Pauli exclusion principle, formulated by Wolfgang Pauli. This principle states that two identical fermions, such as electrons, cannot occupy the same quantum state simultaneously. In practical terms, this means electrons resist being forced into identical configurations. When the electrons in your hand approach those in the wall, not only does charge repel charge, but quantum law forbids certain overlaps outright. Well, the result is additional resistance that reinforces the illusion of solid matter. At the macroscopic scale, these microscopic rules combine across astronomical numbers of atoms. A single atom's behavior might seem abstract, but trillions upon trillions acting together produce certainty. Probability averages into stability. The collective resistance of countless electromagnetic interactions generates pressure. Your skin deforms, mechanoreceptors fire, electrical signals travel through nerves to the brain, and your brain interprets the pattern as touch. What you call contact is a neural interpretation of large-scale electromagnetic interaction. No actual merging of solid substances occurs. The revolutionary implication is that matter is not made of little hard pellets. It is structured energy organized through fields and constrained by symmetry laws. Protons and neutrons themselves are composed of quarks bound by gluons, deeper excitations in quantum chromodynamics. The further inward we look, the more solidity dissolves into dynamics. What seems like stuff becomes structure. What seems like substance becomes interaction. The deeper layer never reveals a final solid brick of reality. It reveals mathematics and relationship. This perspective was articulated with clarity by Richard Feynman, who emphasized that what we perceive as contact is fundamentally electrical in nature. Push against a wall, and what pushes back is not an impenetrable block but an electromagnetic response. There is no deeper, solid core hiding behind that resistance. Hardness is not a primitive property. It is a phenomenon emerging from field interaction. Understanding this does not make the world less real. It makes it more precise. The table is real in the same way a whirlpool is real, as a stable configuration of moving parts. Remove the underlying interactions, and the pattern collapses. But the pattern itself remains meaningful at its scale. Solidity exists as an emergent property of countless interactions obeying consistent laws. It is dependable because the laws are dependable. If you were to remove the empty space inside atoms, compressing nuclei and electrons together, all human beings could fit within a tiny volume. The physical bulk of your body is almost entirely vacuum structured by force, and yet it resists compression because energy rises sharply when charged fields are forced closer. The illusion works perfectly because evolution tuned your senses not for quantum accuracy, but for survival. Resistance is translated into solidity because that translation is useful. So you have never touched anything in the classical sense. When you press your hand against a wall, you are engaging in an exchange of electromagnetic force mediated by field excitations. Your nervous system converts that exchange into sensation. Your mind interprets that sensation as contact. The solidity of the world is not fake, but it is not fundamental. It is a large-scale effect emerging from invisible rules governing charged particles and quantum states. This is the quiet revolution hidden beneath ordinary life. Every step you take, every object you grasp, every surface you feel is maintained by forces you cannot see and gaps you cannot perceive. Beneath the reassuring firmness of the everyday world lies structured emptiness, stabilized by law, animated by fields, and translated by your brain into the illusion of touch. Why you can't pass through the wall. If matter is mostly empty space, if atoms are structured gaps wrapped in fields, if solidity is only electromagnetic resistance, then a deeper question emerges with unsettling clarity. Why can't you walk through a wall? If your body is composed of atoms separated by vast internal emptiness, and the wall is composed of the same kind of atoms, why does emptiness not pass effortlessly through emptiness? The answer does not lie in hidden solid cores buried inside matter. It lies in probability, quantum law, and the extreme stability of organized fields. At the atomic scale, particles are not tiny classical objects traveling along definite paths. Their behavior is governed by wave functions, mathematical structures that describe probabilities rather than certainties. This framework was formalized through the work of physicists such as Erwin Schrödinger, who showed that electrons inside atoms are described by probability amplitudes spread across space. An electron does not sit at a point waiting to collide. It exists as a distribution that determines the likelihood of detection. This alone destabilizes classical intuition. If particles of probabilities smeared through space, then barriers are not absolute walls, but regions of altered probability. Quantum mechanics allows a phenomenon known as tunneling. Under certain conditions, a particle can appear on the other side of a barrier without crossing it in a classical sense. The mathematics does not forbid this. It assigns it a probability. Tunneling is not theoretical speculation, but experimentally confirmed behavior. It plays a role in nuclear fusion within stars and underlies technologies that depend on electron tunneling at microscopic scales. The foundations of these ideas were developed by physicists such as Werner Heisenberg and Niels Bohr, who helped construct the principles of quantum mechanics. If individual particles can tunnel through barriers, then in principle matter is not absolutely impenetrable. But you are not a single particle. You are an astronomical assembly of atoms, each containing electrons, protons, and neutrons, bound in precise quantum states. For you to pass through a wall via quantum tunneling, every relevant particle in your body would need to tunnel in coordinated fashion while preserving the intricate information structure that defines your existence. The probability of one electron tunneling is small, but measurable. The probability of trillions upon trillions doing so simultaneously in an organized manner is so small that it effectively vanishes. Quantum mechanics does not strictly forbid you from passing through a wall, but statistics render it indistinguishable from impossible. The barrier preventing passage is not primarily a wall of stuff. It is an energy barrier. As your atoms approach the atoms of the wall, electromagnetic motion intensifies sharply. Like charges repel, and electrons in both bodies resist proximity. Forcing atoms closer increases system energy rapidly. To overcome that barrier, you would need to supply enormous energy. At everyday speeds and energies, the repulsive force rises long before atomic nuclei could overlap. What you experience as impact is the rapid increase of electromagnetic interaction, converting kinetic energy into deformation, heat, and sound. Beyond electromagnetic the Pauli exclusion principle, formulated by Wolfgang Pauli. Electrons are fermions, and no two identical fermions can occupy the same quantum state simultaneously. This principle is not an added rule layered onto physics. It arises from the fundamental symmetry properties of wave functions. When electrons from your body approach electrons in the wall, they cannot simply collapse into identical configurations. Available quantum states must remain distinct. This restriction produces a form of pressure known as degeneracy pressure, which reinforces resistance to compression. Without this principle, matter would not maintain its extended structure. Atoms would collapse inward dramatically. We observe what happens when matter is pushed beyond ordinary atomic limits in extreme astrophysical environments. When massive stars exhaust their nuclear fuel, gravity can crush their cores to extraordinary densities. In certain cases, electrons are forced into protons, forming neutrons in a process predicted through stellar collapse calculations by physicists such as Subramanian Chandrasekhar. The result is a neutron star, an object so dense that atomic structure ceases to exist in its conventional form. The empty space inside atoms effectively disappears under immense gravitational pressure. Matter becomes radically compressed, but this is not a gentle merging of emptiness through emptiness. It is violent restructuring under gravity strong enough to warp space-time itself. Ordinary walls in human bodies are nowhere near such conditions. The stability you experience is the default state of balanced forces, not a fragile boundary waiting to dissolve.
We observe what happens when matter is pushed beyond ordinary atomic limits in extreme astrophysical environments. When massive stars exhaust their nuclear fuel, gravity can crush their cores to extraordinary densities. In certain cases, electrons are forced into protons, forming neutrons in a process predicted through stellar collapse calculations by physicists such as Subramanian Chandrasekhar.
The result is a neutron star, an object so dense that atomic structure ceases to exist in its conventional form. The empty space inside atoms effectively disappears under immense gravitational pressure. Matter becomes radically compressed, but this is not a gentle merging of emptiness through emptiness. It is violent restructuring under gravity strong enough to warp space-time itself. Ordinary walls in human bodies are nowhere near such conditions. The stability you experience is the default state of balanced forces, not a fragile boundary waiting to dissolve. Even high-speed collisions do not eliminate the underlying interaction-based nature of solidity. When a car strikes a concrete barrier, the atoms still do not touch, as classical intuition suggests. Instead, electromagnetic forces spike, molecular bonds break, and energy redistributes explosively. Chemical and structural integrity fail, but the fundamental rule remains unchanged. Nuclei rarely overlap, and quantum constraints continue to operate. Destruction at the macroscopic level does not imply classical contact at the microscopic level. It reflects the overwhelming of structural bonds by energy transfer. Hardness itself is not a property of packed matter, but of bonding strength and lattice structure. Steel feels harder than wood because its atomic arrangement resists deformation more strongly, not because it contains less empty space. Diamond resists scratching because carbon atoms form an exceptionally rigid network through covalent bonding. Yet even the hardest diamond is mostly empty at the atomic scale. Hardness measures resistance generated by electromagnetic bonding patterns, not the absence of internal space. Modern quantum field theory pushes the explanation deeper still. What we call particles are excitations in underlying fields. These fields fill all space. When you press against a wall, you are not bringing two clusters of miniature marbles into collision. You are bringing two complex excitation patterns into proximity. Forces arise from interactions between these excitations, often described as exchanges of virtual particles within the mathematics of the theory. The apparent impenetrability of matter is the macroscopic manifestation of stable field dynamics maintaining consistent energy configuration. Even what we call empty space is not truly empty. Quantum theory predicts fluctuations in the vacuum state, subtle manifestations of field activity even in the absence of real particles. Physicists such as Paul Dirac recognized that the vacuum in quantum theory is not a simple void, but a structured baseline state. This means that when we describe atoms as mostly empty, we refer only to the absence of localized matter, not to the absence of fundamental fields. You are never encountering literal nothingness when you approach a wall. You are encountering an elaborate configuration of fields whose energy rises steeply as overlap is attempted. Thus, the wall is not a barrier because it is filled with solid bricks of matter. It is a barrier because its internal field configuration resists reorganization. To pass through it without destruction, you would need to rearrange trillions of quantum states in perfect coordination while overcoming electromagnetic and exclusion-based energy costs. That requirement defines a probability, so vanishing that it effectively forbids passage in practice. The universe does not forbid the impossible lightly, it suppresses it through mathematics. Your body, like the wall, is a dynamic equilibrium of interacting forces. Atoms vibrate, electrons transition between energy states, molecules assemble and disassemble, yet the large-scale structure persists. This persistence gives rise to the appearance of solidity and identity. When two such stabilized patterns encounter each other, their interaction enforces separation. What feels like a hard stop is the universe defending energetic consistency. You cannot pass through the wall not because it is packed solid with impenetrable substance, but because the probabilistic and energetic cost of reorganizing two massive quantum systems into overlapping configurations is overwhelmingly large. Electromagnetic repulsion rises exponentially with decreasing separation. The Pauli exclusion principle prohibits identical fermions from sharing states, and statistical suppression eliminates coordinated tunneling at macroscopic scale. The barrier is not material in the classical sense, it is relational. It arises from how fields respond to proximity. The conclusion is stark and unavoidable. The wall resists you because of interaction, not because of compact matter. Emptiness does not pass through emptiness, because what appears empty is structured by fields and governed by strict quantum rules. Solidity survives not as a primitive property, but as an emergent effect of deep symmetries and conserved quantities. The world holds together and holds you back, not through hidden chunks of solid stuff, but through the relentless enforcement of energy, probability, and quantum law. I have nothing touches what is real. If you have never truly touched anything, if solidity is electromagnetic resistance and quantum exclusion rather than literal contact, then the final question becomes unavoidable. What exactly is real? If matter dissolves into fields, if particles dissolve into probabilities, if even hardness is an emergent effect, then what is the foundation beneath all of it? The answer does not return us to solid ground. It takes us into a deeper layer where objects give way to relationships and space itself may not be fundamental. We began with atoms and discovered emptiness structured by force. We then examined why that structure cannot simply dissolve when two bodies approach each other. Now we must confront the substrate that allows any structure to exist at all. Quantum field theory describes reality not as isolated particles moving through a vacuum, but as continuous fields that exist everywhere. These fields are not placed inside space as objects are placed inside a box. Rather, they define what space is. An electron is an excitation of the electron field. A photon is an excitation of the electromagnetic field. Remove the excitation, and the field remains. Remove all particles from a region, and the vacuum still contains the fields in their lowest energy state. This insight emerged through the work of theorists such as Richard Feynman, Julian Schwinger, and Shinadero Tomonaga, who helped construct quantum electrodynamics and formalize the field-based picture of matter. In this framework, what we call particles are not enduring lumps of substance, but quantized ripples in underlying fields. The world is not built from bricks, it is composed of excitations. Stability is pattern, not material solidity. Even emptiness is not simple nothingness. Experiments reveal that the vacuum exhibits measurable effects. Quantum fluctuations cause pairs of particles and antiparticles to momentarily appear and vanish within the limits allowed by uncertainty. This restless background means that space is never a blank void. It is a structured state with defined properties. When two metal plates are placed extremely close together, measurable forces arise from vacuum fluctuations between them. The absence of matter does not imply the absence of activity. What we casually describe as empty space is a dynamic baseline, defined by quantum fields. If fields are fundamental, then objects become secondary constructions. A chair is not a thing in isolation. It is a stable arrangement of field excitations maintained by electromagnetic interactions and constrained by quantum rules. Your body is built from the same fields, configured differently. The apparent distinction between you and the chair lies in organization, not substance. Identity is pattern preserved through time. The stability of that pattern gives rise to what you call a self. This leads inevitably to space-time. General relativity, formulated by Albert Einstein, describes gravity not as a force but as curvature of space-time itself. Mass and energy shape geometry, and geometry guides motion. Yet quantum field theory treats fields as defined over space-time. This creates a conceptual tension. Is space-time the stage on which fields act, or is it itself a product of deeper relationships among quantum entities? Modern theoretical attempts at unification explore the possibility that space-time is emergent rather than fundamental. In some approaches, distance may reflect the strength of interaction between underlying quantum degrees of freedom rather than an absolute background grid. What appears as physical separation could arise from relational structure. If separation is relational, then boundaries are emergent too. You experience your skin as the edge of your being, yet at the microscopic level there is continuous exchange of particles and radiation. Photons strike your body from distant stars. Air molecules collide with your skin and enter your lungs. Gravitational fields from remote galaxies influence you infinitesimally. There is no perfectly sealed border between you and the universe, only gradients of interaction intensity. The sense of isolation is a large-scale simplification of deeply entangled processes. Objects persist because their internal interactions maintain stability. Consider a whirlpool in a river. The water molecules composing it constantly change, yet the pattern remains. Similarly, the atoms in your body are replaced over time, but the organizational structure continues. You are not a static collection of matter. You are a dynamic equilibrium, sustained by energy flow and interaction. The wall you cannot pass through is another equilibrium configuration. When the two configurations meet, their fields respond in ways that preserve energetic consistency. The result is resistance that you interpret as solidity. The deeper illusion, therefore, is not that matter is fake. It is that reality is made of independent things. Quantum theory suggests that relationships, symmetries, and conservation laws are more fundamental than objects. Particles gain identity through quantum numbers. Forces arise from gauge symmetries. Stability emerges from permitted states. The universe appears less like a warehouse of stuff and more like a self-consistent mathematical network of interactions. Conscious experience sits within this network. Every sensation you call touch, sight, or sound arises from physical interactions, translated into neural signals. When you press against a wall, electrical impulses deform skin tissue. Ion channels open. Electrical impulses travel through neurons, and the brain constructs a coherent perception of contact. The experience is real, but it is a model built from interaction data. You never encounter the wall directly in any fundamental sense. You encounter signals generated by field interaction. Despite this abstraction, macroscopic solidity remains robust. Statistical mechanics ensures that enormous numbers of microscopic interactions average into reliable outcomes. Probability distributions for individual particles may be spread out, but the collective behavior of trillions produces near certainty. The suppression of macroscopic quantum anomalies guarantees that walls behave like walls. The emergent world is extraordinarily stable because deviations from stability are exponentially improbable.
The final understanding is both humbling and profound. You stand, walk, sit, and lean within a universe that feels solid. Yet that solidity is a consequence of invisible constraints governing charged fields and quantum states. Space is not an empty container but a structured fabric infused with fields. Matter is not substance but excitation. Contact is not collision of solids but resistance generated by interaction laws. Boundaries are not absolute divisions but energetic gradients.
When Richard Feynman spoke about understanding nature, he emphasized that explanation does not eliminate wonder. It replaces naive certainty with deeper mystery. The world does not dissolve when solidity is revealed as emergent. It becomes more intricate. Every surface you feel is a manifestation of electromagnetic symmetry. Every step you take is supported by quantum exclusion and field dynamics. You move not through a universe of compact matter, but through structured emptiness held rigid by law.
Nothing truly touches. What remains real is interaction itself. Forces, symmetries, probabilities, and conservation principles form the backbone of existence. Objects persist because interactions stabilize them. You exist because patterns endure. The wall resists you because energetic configurations defend themselves. Reality is not built from things, but from relationships that maintain coherent structure across time. You are not separate from this structure, you are one of its sustained expression.